Hi students, I am Reverend Sebastian Paul. In this lecture, we are discussing the working of a full wave rectifier with the help of a center tapped transformer. So as we mentioned, the rectification is the process of creating a DC output while we are providing an AC input. So these AC inputs are converted as DC output with the help of the diodes, and generally these output signals are pulsating DC signals. A full wave rectifier is a rectifier concept which converts both the positive and negative half cycle of an AC signal into a pulsating DC signal. When it comes to a center tapped full wave rectifier, it is a type of rectifier which uses a center tapped transformer and two diodes to convert the complete AC signal into a DC signal. The center tapped full wave rectifier is made up of an AC source, a center tapped transformer, two diodes, and a load resistor. The AC source is connected to the primary winding of the center tapped transformer. A center tap connected to the exact middle of the secondary winding divides the input voltages into two parts. The upper part of the secondary winding is connected to the diode D1 and the lower part of the secondary winding is connected to the diode D2. Both diodes D1 and diode D2 are connected to a common load resistor RL with the help of a center tap transformer. The center tapping is generally considered as the ground point or zero voltage reference point. The center tap full wave rectifier uses a center tapped transformer to convert the input AC voltage into output DC voltage. When input AC voltage is applied, the secondary winding of the center tapped transformer divides the input voltage into two parts, that is positive and negative part. During the positive half cycle of the input signal, the terminal A becomes positive and the terminal B becomes negative, and the center tap is grounded towards 0 volt. The positive terminal A is connected to the P side of the diode D1 and the negative terminal B is connected to the N side of the diode D1. So the diode D1 is forward biased during the positive half cycle and it allows the electric current to flow through it. On the other hand, the negative terminal B is connected to the P side of the diode D2 and the positive terminal A is connected to the N side of the D2. So the diode D2 is reverse biased during the positive half cycle and it does not allow the electric current to flow through it. The diode D1 supply a DC current to the load resistor RL. The DC current produced at the load resistor RL will return to the secondary winding through a center tap. During the positive half cycle, the current flow only in the upper part of the circuit while the lower part of the circuit carry no current to the load because the diode D2 is reverse biased. Thus, during the positive half cycle of the input AC signal, only the diode D1 allow the electric current while the diode D2 does not allow the electric current to flow through it. During the negative half cycle of the input AC signal, the terminal A becomes negative and the terminal B becomes positive and the center tap is grounded towards the 0 volt. The negative terminal A is connected to the P side of the diode D1 and the positive terminal B is connected to the N side of the diode D1. So the diode D1 is reverse biased during the negative half cycle and does not allow the electric current to flow through it. On the other hand, the positive terminal B is connected to the P side of the diode D2 and the negative terminal A is connected to the N side of the diode D2. So the diode D2 is forward biased during the negative half cycle and it allows the electric current to flow through it. The diode D2 supplies the DC current to the load resistor RL and the DC current produced at the load resistor RL will return to the secondary winding through a center tap. During the negative half cycle, the current flow only in the lower part of the circuit, while the upper part of the circuit carry no current to the load because the diode D1 is reverse biased. Thus, during the negative half cycle of the input AC signal, only the diode D2 allow the electric current, while the diode D1 does not allow the electric current. Thus, the diode D1 allow the electric current during the positive half cycle, and the diode D2 allow the electric current during the negative half cycle of the input AC signal. As a result, both the half cycles, that is the positive and the negative half cycle of the input AC signal, are allowed, so the output DC voltage is almost equal to the input AC voltage. The diodes D1 and D2 are common connected to the load resistor RL, so that the load current is the sum of the individual diode current. We know that the diode allow electric current in only one direction. From this diagram, we can see that both the diodes D1 and D2 are allowing the current in the same direction. We also know that the current that flow in only single direction is called a direct current. So the resultant current at the output load, that is a load resistor RL, is a direct current. But the direct current appeared at the output is not a pure direct, but a pulsating direct current. The value of the pulsating direct current changes with respect to time, and this is due to the ripples in the output signal. These ripples can be reduced by using a filter such as capacitor and inductor, and the average output voltage across the load resistor is double that of the single half wave rectifier circuit. The output waveform of the circuit is shown in this figure, and the first waveform represents an input AC signal, the second waveform and the third waveform represents the DC signals or the DC current produced by the diode D1 and diode D2. The last waveform represents the total output DC current produced by both the diodes D1 and D2, which is across the load resistor RL. From this waveform, we can conclude that the output current produced at the load resistor is not a pure DC but a pulsating DC, and this pulsating DC can be converted into a smooth DC signal with the help of a filter circuit. So dear students, hope you had understood this topic. So dear students, kindly write down the assignment question. Our question is, write notes on the full wave rectifier circuit with the help of a center tapped transformer. So dear students, in the upcoming lecture we will discuss the full wave rectifier with a filter circuit. So dear students, see you soon. Until then, goodbye. Thank you and all the best.